There. Thought we'd spend some time working some more problems on the semester 1A final exam review for Algebra 1. So if you missed problems 1 through 12, I'll link that video in the description below so that you'll be able to go back and do that. Hopefully, as we go through these problems, you'll be getting some good tips, some notes, so that when you take that final exam, you've got your review sitting right there. When you look at problem number 13 on the test, I want you looking right at problem 13 on the review and remembering exactly what we did to help you do your very best on the final exam. That being said, as we get started, if you have questions or comments, put them in the comments below. I'll be glad to help with those if you need that. So let's just jump right in. Number 13 is what we're picking up with in this video. It says on a trip to Buffalo, from Buffalo to St. Augustine, a family wants to travel at least 250 miles in the first hour of driving. And I want you to key in on those words at least, because those are indicating that we're not doing an equation, we're working with an inequality here. And so if we want to go at least 250 miles in the first 5 hours of driving, I want you to remember, and I'm going to write an equation here, but although we're not going to do an equation, okay? It's just to remind you from your work in probably a good science class. So we know that distance is rate times time. Okay, rate being your speed. We don't know your speed. That's what we're actually looking for. So I'm going to put a variable there, maybe like r, times time, which we said was in the first 5 hours of driving. We want to go at least. Now, at least means greater than or equal to your distance, which is your 250. So friends, remember how I wrote that out. I did my rate, which was my speed, times time, and then at least is telling me greater than or equal to, and then my distance, okay? Now remember, other keywords to know, at most would have meant less than or equal to. Okay, I have that in your notes just in case, because you know the problems on the test are going to be slightly different than the review. Not that much, though. All right, friends, notice how do we solve this now that we have it set up? Well, I see that the variable is being multiplied by 5. So I'm going to do the opposite of multiplying by 5, and that's to divide by 5. That leaves me with r, because notice my multiply by 5, my divide by 5 cancels, leaving me with r is greater than or equal to 50 miles per hour. So we'll include those units here. And voila, we have solved that one. Okay, look at number 14 then. We're going to solve and graph. Okay, so the solving, we're going to look at what's happening to the variable. It's being multiplied by -7. So we're going to do the opposite of multiplying by -7, which is to divide by -7. When we divide by a -7, we run into that one rule with inequalities that is different than equations. So let's write it out. When we multiply or divide by a negative number, we flip the inequality. So if we multiply or divide by a negative number, we have to flip that inequality. This case, it's a less than. We're going to flip it to a greater than. Now, friends, that's a really good one. So you know I'm very colorful when I do math. Are you? Yeah, it makes it a little fun, doesn't it? So I'm going to highlight that because that's a really important rule. And I'm going to go ahead and do x is now greater than, and then 63 divided by -7. If you need to check that in your calculator, please do. And then let's go talk about how to graph this. We're going to put -9 on my number line somewhere. Doesn't have to be in the middle. I'm just kind of one of those people that likes to do it the same every time. So I put it in the middle. Now, because it is just a greater than, There's no equal to underneath it. We're going to put an open circle. So if there's no equal to with it, we put an open circle. Ah, that sounds like a good note we need, right? Less than or greater than is open circle. All right, now if x is greater than, do you see how that inequality is pointing to the right? That means we're going to shade to the right of -9. And I'm going to shade all of this part of the number line. Now, friends, your exam is going to be multiple choice. You're going to be looking for which graph. I want you looking for the open or closed circle, whichever one it should be. And I want you looking for the direction that it's shaded. Make sure it's shaded to the correct side. Okay. All right. Now, number 15, moving along. Oh, I got to highlight my answer. You know I like my colors. Okay, let's look at number 15. Now, for this one, we're asked to do two inequalities, right? We're asked to solve both of them. So let's do that. Remember, we'll use our same techniques that we use when we're solving equations. So ask yourself what's happening to the x. It's being multiplied by 4, being subtracted by 9. So let's do the opposite of subtracting 9, which is to add 9. And that gives me 4x is less than 16. And then we do the opposite of multiplying by 4, which is to divide by 4. So x is less than 4. Now, if we go to our number line, we'll put the 4 on there. It's going to be an open circle. Remember our notes, right? Less than or greater than is an open circle. So we'll put an open circle at 4. And look at that arrow. It's pointing to the left. That means we're going to graph to the left. Okay, now let's do the same thing for the second inequality. I have 3x minus 10 is greater than 5. What's happening to your variable? It's being multiplied by 3, being subtracted by 10. So we do the opposite of subtracting 10, which is to add 10. That gives me 3x is greater than 15. Then we're going to divide by 3. That gives me x is greater than 5. So we'll put 5 on our number line. It's a greater than, which tells me it's an open circle. So I'm going to put an open circle there, and then I'm going to shade to the right. And there you go. Because it has an or, we're looking to shade both of them and see what kind of graph we get. So we put both of them on the same number line is the point. Okay, and I'm going to use the word or between them. Yeah, looks really good there. Okay, so the big takeaways from inequalities, we solve them the same way we do an equation, but we've got that one big rule. If we multiply or divide by a negative number, we flip the inequality around, and then we add the element of graphing with it. All right, friends, good work so far. Let's keep going to problem number 16. Oh, and we get a freebie. Don't you just love freebies? Okay, so here we go, friends. When you see these, I don't want you to miss them. That means don't freak out when you take the exam that you get a problem that you might not know, okay? Just, I would guess, don't leave it blank, just guess, but know that you're going to get credit for that problem when I add points back to it, okay? So keep that in mind. It'll be a really nice treat for you. Okay, let's look at 17 then. The table shows the total number of customers at a car wash. After 1, 2, 3, and 4 days of its grand opening, which graph represents the data as well? Okay, so friends, I want you to notice that as the days go up, notice that the total number of customers goes up. Okay, so think about that. Because when you see this, the days go up the customers are going down. C won't work. The days go up, the customers come down. D won't work. Folks, I'm in a 50-50 guess if I have to. I'm not going to have to because you're going to be able to study and figure it out, but I've narrowed it down. Okay? Now, let's take a look at the change in the number of customers. So the difference here is 64. I subtracted them to get that number. Okay? And then the difference here is 52. And the difference here is 65. So my idea is that I'm going up by quite a bit. Now, the least amount that I went up by was between days 2 and 3. But then I went back up by 65. So which of them shows the least amount of increase between days 2 and 3? Is it from here to here, or is it from here to here? I think it's A as well. Yep. I think it's A because look at the increase, right? From day 1 to 2, we had a pretty good increase. Then we had less of an increase, meaning it didn't go up as much. It still went up, but not as much. And then we're back to having a really big increase. Compared to this one, we increased, then we increased not as much, and then we increased not as much again. Okay? So you have to look at, first of all, get it down to 2 graphs by looking at the going up, going down part, and then look at the amount of increase. I think that's going to help you here with this particular type of problem. Okay, let's go on then to number 18. So number 18 says the table shows the relationship between two variables. Which one describes the relationship? Okay, so I want you to notice the x values are going up. What's happening to the y values? Are they going up or are they going down? Are they increasing as you move down the list or are they decreasing as you move down the list? You're right. It's increasing. So folks, cross out C and D. They are not going to work for us. Okay, we've got the increasing. Now I want you to look at the amount of increase, just like we did on the previous problem. And again, you can subtract. So how much does it take you go from -3 to -1? That's 2. Think about it. Go from -3, -2, -1, right? How much does it take you to go from -1 to 1? Start at -1, go 0, go 1, 2 again. Go from 1 to 3. Start at 1, 2, 3. Now notice that those all came out to be the same amount. When they come out to be the same amount, that is increasing. And sorry, when it comes out to be the same amount, that is linear. If those don't come out to be the same amount, it is nonlinear. That's how you're going to tell from a table whether it's linear or not. All right, good work there. Keep going. We're on question number 19 here. Suppose laundry detergent is on sale for $12.99 each, but you are the lucky one and you have a coupon for $1.50 off the total purchase. Notice that is not per laundry detergent. It's $1.50 off your total purchase. So write a function rule for this. We're going to write a function rule, and I'm just going to call it f of n. And we're going to let n be the number of laundry detergent. Now, each of those laundry detergent are $12.99. So when we go to pay for the laundry detergent, we've got to pay $12.99 for each. So, meaning if I have 6 laundry detergent, I'm going to pay $12.99 times 6. If I have 10 laundry detergent, I'm going to pay $12.99 times 10. If I have n laundry detergent, I'm going to pay $12.99 times n. Then I get to take my coupon off, right? Because my coupon is not for each laundry detergent. It's not $1.50 off each one. It's $1.50 off the whole purchase. So here's my whole purchase. I'm going to take $1.50 off. Now, do you think I'm going to add $1.50 or do you think I'm going to subtract $1.50? You're right. I'm going to subtract $1.50. Well done. That is exactly right for my function for the number of bottles, for the purchase of the bottles of laundry detergent. All right, so far so good. We're on question number 20. We're trying to look at these mappings in question 20 and decide which one represents a relation that's not a function. So let's put some notes over here to the side so you know what you're looking for. When you are looking for not a function, you are looking for an x to arrow to two different y's. And I abbreviated two different y's. So you're looking for an x to go to two different y's. Now these mappings, we have to remember that x is on the left and y is on the right. So look at your x's. They're each being mapped to one y. This is a function. Look at number or letter B. Each x is being mapped to one y. This is a function as well. But look at the C. We have 2 being mapped to 4 and 2 being mapped to 3. I'm going to highlight it so you know exactly what I was looking for on my review. That's what makes it not a function. Not a function because that's what I'm looking for, that an x went to two different y's. All right, good work. Let's keep going. We're on problem number 21 next. And in problem number 21, we are asked whether the sequence is arithmetic. If so, what is the common difference? So let's explain what arithmetic means. Means we add the same number every time. We add the same number every time. So remember, we've got to ask, what did I add to this first term to get the next term? What did I add to -6 to get 2? I got 8, right? I added 8. What did I add to 2 to get 10? I added 8. What did I add to 10 to get 18? I added 8. You're right. Good. Because I added the same number every time, yes, it is arithmetic. Because it's arithmetic, now it's asking you, what is the common difference? Let me translate that to you. What is the number you add each time? That's really what that question is saying. And because we already did the work, right? We can say the common difference is 8. That's what we added at each time. So that's what we tell. Now, if it's not arithmetic, then you can't have a common difference because you didn't add the same number each time. Okay, good work so far. All right, friends, we've got another freebie here on number 22. Remember what we do on freebies? We guess, but then we don't sweat it. We don't get upset because we know we're going to get credit for that question later on. So no worries on that. I want you to really think about it. Just make sure you guess on that so that, yeah, you could guess, right? All right, let's keep going and move on to number 23. So 23 is asking us, does y vary directly with x? If so, write the equation. So here's what we got to look at. Do you remember how we looked at what was the increase amount each time? We're going to do that again, okay? And because it's written in a chart, it's going to be super easy for us to organize our information. So here's what I need you to do. I want you to say, okay, what did we add to 2 to get 6? Well, we added 4. And what did we add to 5 to get 15? We added 10. Good for that. Okay, let's do the next one. What did we add to 6 to get 10? We added 4. And what did we add to 15 to get 25? We added 10. Now, friends, it's not as important that we got 4s and 4s and 10s and 10s. What's more important is that when we do 10 over 4, we get the same thing as we have here, 10 over 4. That's the important part, okay? Now, let's write the equation, okay? So I've got y equals, and then this value that you just found, that 10 over 4, goes in front of x. And that's our equation. Now, if you want to test it, let's test it. We're going to use the point 10, 25. I'm going to put in 25 for y and 10 for x. So 25 for y and 10 for x. And I need to see if this is true. So I've got 25 equals, now friends, I probably would put this in my calculator, right? 10 divided by 4, then multiply by 10. 10 divided by 4, you're going to get 2.5 in your calculator. And then you're going to multiply it by 10, you're going to get 25. And that, friends, tells me that yes, y varies directly with x. And we've already found our equation for that too. So use your chart wisely when you find the amount of increase there. Now, I'll give you a heads up too. You could find the amount of decrease. You could find that those are decreasing, and that's okay. The only difference is when it decreases, then this number comes out to be a negative, and we would have a negative number there. It's totally fine that that happens. I just want you to be aware of it. Okay, we'll do just a few more here in this video. And then don't forget, if you need to see the other problems on the review, I'll link them in the descriptions below. So friends, we're going to graph this equation. And we're going to graph it here. So let's get it in what is the graphing form. We're going to get it into y equals mx plus b form. That may sound familiar. That's our slope-intercept form. And notice in slope-intercept form that the y is by itself. That's the key thing, is when we've got this equation in slope-intercept form, we get the y by itself. So let's do that. Now, what's happening to the y? It's being added by 4x, and it's being multiplied by negative 3. So we're going to take care of the adding 4x part first by doing the opposite of adding 4x, which is subtracting 4x. Now, friends, I don't write that minus 4x underneath the 12 because I don't want to think that I can subtract 12 minus 4x, because I can't. Remember, they're not like terms, so I can't subtract them. Instead, I just write them side by side. And I notice that my 4x minus 4x will cancel. I'm left with negative 3y equals, I like my x's to come first. See how my x comes first in this equation? So instead of writing 12 minus 4x, I'm going to write negative 4x plus 12. You can do that, and it makes it a little bit easier. Now I'm going to divide, because I got to get rid of this multiplying by -3. I'm going to divide by -3 on both sides. Now watch how I divide by -3 on this right side. I divide this term by -3, and I divide this term by -3. I do it individually because it makes it easier for me to simplify. Now notice that my multiply by 3, my divide by -3 cancel, giving me y equals negative divided by a negative gives me a positive 4/3 x. And then I've got 12 divided by -3, which is -4. Now you did all of that great work. Let's point out this is my slope, and this is my y-intercept. So where do we start? We start on the y-intercept. So I'm going on my y-axis down to -4. 1, 2, 3, -4. And then I'm going to use my slope. Now remember, in my slope, I'm going to run the top number. So I'm going to run 4. Sorry about that. I'm going to rise 4. And I'm going to run 3. I'm going to rise 4 and run 3. So from the y-intercept, you're going to rise 4. 1, 2, 3, 4. You're going to run 3. 1, 2, 3. Do it again one more time. From here, you're going to rise 4. 1, 2, 3, 4, and run 3. 1, 2, 3. Why do I do 3 points? It makes it a little easier to line up my straight edge. And friends, I'm no fancy here. This is a Sonic gift card, but it's a nice straight edge. If you have a ruler, you're good. If you don't, all you need is something straight to draw your line. But I just like straight lines. So, and there's my equation or there's my line graphed. All right, look at 25. It said, okay, find the slope of this line. We've already done that, right? We already identified the slope here. The slope is 4/3, right? It's that number in front of x once we're in the slope-intercept form. Okay, one more. Let's do one more. Oh, forgive me. This was cut off. Let's look at 25. 25 was referring to this graph, not the line before it. Scratch the 4/3 there. Let's look at this line and see if we can find its slope. Forgive me, that was ran on 2 different pages and it made it a little difficult. So friends, when you're looking at a line and you're asked to find the slope of it, I like to pick out some points. If I can hit the axis exactly, makes it a little easier. And then you can choose any other point that lands on a perfect grid. Like you could use this one, or this one, or this one, or this one, or even this one down here. You just need 2 points to count from, okay? I always count from the point on the left. So I always start with this point here. And remember, I'm counting the rise over the run. So what I'm counting is I'm counting this much, and then I'm counting this much. So let's count. Now, it says to count the rise, but I'm going down. That simply means I'm making it a negative. So I'm going 1, 2, 3. So my rise is -3. Then I'm going to run. Well, I'm probably going to walk, but that's okay. You know what I mean. 1, 2, 3, 4, 5, 6. Now, friends, 3 and 6 are both divisible by 3. If you want to use your calculator to reduce, you definitely can do that. I'm just going to write it out here because that looks pretty easy. I can do that. -3 divided by 3 gives me -1. And then 6 divided by 3 gives me a 2. Okay, friends, I'm going to stop here for this video. I'll link the other problem sets, the videos for the other problem sets in the description. But thanks so much, and we'll see you soon. Bye for now.